All right, thank you. Well, I want to believe that others are no longer part of this class. So I've waited for how many minutes? 18 minutes. So I'm constrained to start so that I don't delay other people unnecessarily. All right, so today we'll be looking at software architecture and a few other things that we need to learn. So today I'm going to be a bit fast so that I can complete my time. Okay, so to create a reliable, a secure, and an effective product, we need to pay attention to the architectural designs, which includes its overall organization, how the software is decomposed into components, the server organization, the technology that you use to build the software. That is, the architecture of a software product affects its performance, its usability, security, reliability, and maintainability. All right, so there are a number of things that should be considered even when you are starting a regular project. For instance, if you need to get a structure erected, there's a need for you to put in place a number of things before you could start, right? The first thing is that we should get, at least it's important that you get a piece of land, right? You do the clearing, right? So once the land is cleared, then you dig up a foundation, then you can do the initial blinding, then you lay the foundation. Now, you are not supposed to be probably guessworking when you are laying the foundation. Before the foundation is laid, where every component or that, okay, every component that makes up the house will be located is already mapped out. For instance, where the kitchen will be is already mapped out. Where the bedroom will be is already mapped out. Where the laundry and other places will be located is already mapped out, right? And also the link to these spaces will also be marked out from the beginning. For instance, you may not have to raise up the four walls of every room that you have because one, you have to provide a space called door where you have to come out. And also this door must be wide enough to take your furniture. It should be tall enough to accommodate your height. At least they are standard doors, but some people can be very tall, probably more than 6 feet. And of course, I think a regular door, it's probably more than that. I'm not too sure because I'm not um, I'm not a building expert, right? So, okay, yeah. So all these things we have to be decided upfront. So the overall organization of the building has to be decided. Now, how the software is decomposed into components, how each of these places that you called in your building, how they are decomposed. Of course, you cannot just have a huge space and you now probably put your stove and stuff by one corner and you call it kitchen. No, it has to be demarcated with some maybe wood or blocks to at least make it stand out or stand alone component. The bedroom and every other places have to be demarcated, right? The server organization, that means how do you want to get information in and out to the system? The doors, right? We have to be well designed in such a way that you can get easy access. Then your security will also have to be well guaranteed. The technology that you use to build the software, for instance, so in some places in the US, their buildings are completely erected using wood, right? But here in Nigeria, we are accustomed to the use of concrete and sand or something just to get the building. So the technology you are going to adapt, it's also of great importance. Now, the architect of a software product affects its overall performance, right? Usability, security, reliability, and maintainability. Just as in the case of that building, its overall security, reliability, maintainability, usability should be part of what you factor in, right? Considering your budget, right? Considering your technical expertise, considering the technology you are adopting, right? Now, and also considering the land space that you have. So we'll be looking at some of these factors as we go on. So there are many different interpretation of the term software architecture. Now, some focus on architecture as a noun, right? The structure of the system. Another consider architecture to be a verb, the process of defining these structures. However, the UU organization defined software architecture as the fundamental organization of a software system embodied in its components, their relationship to each other, and the environment, and to the environment and the principle guiding its design and evolution. So software architecture has to do with fundamental organization of components and how these components relate to each other in a particular environment based on some principle guiding it in its design and also its maintenance or its evolution. When I mean evolution, if you are using the agile process, the frequent releases that you have is called the evolution or the maintainability, right? So software architecture and its components. So the first thing is architecture is the fundamental organization of software system embodied in its components. So we want to look at the components that makes up software architecture. So for a starter, a component is an element that implements a coherent set of functionalities or features. Now, I'm sure when we're doing feature scenarios and stories, you know what features are and you know what functionalities are. Now, software components can be considered as a collection of one or more services that may be used by other components. Now, listen to that. Software component can be considered as a collection of one or more services that may be used by other components. So when designing software architecture, you don't have to decide how the architectural element or component is to be implemented. Rather, all you need to do, you design the components interface and leave the implementation of that interface to a later stage of development process. Okay. Now, so you have, sorry. Okay. So service accessed directly by other component. The other diagram, service access through the component API. So the first one is component one, has access to service provided by software components. Access to services provided by software component. Now, you have S1, S2, S3 as software components. Now, and the access is, for the first diagram in component one, the service is accessed directly by other components. So there's no interface between them at all. So there's a direct access to the services provided by this software component. But the other one, it has to go through an API before the services are accessed. So why is architecture important in software design, right? Architecture is important because the architecture of a system has a fundamental influence on the non-functional system property. So what are non-functional system properties? We'll look at that shortly. So architectural design involves understanding the issues that affects the architecture of your product and creating an architectural description that shows the critical components and their relationship. So the critical components are known as the functional requirements. Then the relationship is called the non-functional requirements. So for instance, if if you have not learned how to drive a car, for instance, it will be quite difficult for you to be able to teach somebody effectively on how to drive a car. Now let's assume that you have even learned how to drive a car. You know, some people will just say, guy, my friend has just got a new car. So maybe he's just going on the road, and of course the road is quite free. You know, I say, please, let me quickly learn how to move the car. So probably that's about the first time you're able to throttle a car. You get in, you strap yourself in, and you start pressing the accelerator, and the car starts moving. And gradually you continue, and you feel, no, that's about all that you need to learn. Now, what about the road safety, the road signs, the rules of governing the usage of road that you have not learned effectively? So if you are supposed to describe the method, right, that is used to teach somebody how to drive, what you probably pass out to the person is that just enter the car, strap yourself in, press the accelerator, and move on. But if you have gone to a driving school, right, you would have been taught the rudiments of the laws governing the use of road, the signs, right, what you are supposed to look out for, the positioning of your hand. Now, for you to now develop an architecture for a driving school, right, your architecture will be more robust than that individual who has not gone to a driving school. Now, you'll be able to empathize, you're able to sympathize, and you're able to put yourself in the shoes of the new person. What did you go through when you were learning how to drive? What were your fears? What were the things how did you overcome those fears? Will be part of those things that you put as your recommendation in your architecture, right? Which will make it easier for that individual to learn rather than making very hard and cumbersome or looking very like all you need to do is just to press the accelerator and you move on. So designing a software architecture requires that you put yourself in the user's position. You look at other things that can affect that user and put it as part of your architectural design. So your experiences, right, contribute to how good the software architecture will be, and how you will describe the critical components and how those components relate to the hardware, to the user, to the technology that the user is having. Maybe the person is having a very slow system. How would you still adapt that technology, that architecture to suit the user, or are you going to recommend that the person upgrades? Now, if you have not deployed your architecture, your software on a very slow system, you may not be able to tell us the requirements for the system to be deployed. So though the functional requirements are, okay, you do this, you do this, the non-functional requirements are those that helps the performance of the system to optimally perform to the best of its abilities, right? So minimizing complexity should be an important goal for architectural design. So what is complexity? Right, now, of course, if you have done something on algorithm and complexity, you look at some algorithms are linear in their complexity. Some are logarithm All right, some are exponential, some are square. Now, the more the complexity of an algorithm, the more it is for it to run into problems, and also the more it takes a longer period for it to accomplish the solution that it seeks to accomplish. So, as a software engineer and as an architectural designer, you should minimize complexity as much as possible. So, the more complex a system, the more difficult and expensive it is to understand and change. So programmers are more likely to make mistakes and introduce bugs and security vulnerability when they are modifying or extending a complex system. So you should at least make your architectural solution to be at least in a range where a little increase in input size, the system can still cope with it without having to maybe introduce too much complexity in your architectural design, right? So what are the non-functional requirements quality attributes? The first one is the responsiveness. Now, does the system return results to users in a reasonable time? So you see, that is not part of the functional requirement, but it is a measure of how the system works. So if you have to design an architecture for a software, right? I haven't designed the component for the functional requirements. You should also take cognizance of the non-functional requirements, which in a sense will make the system or the software you have designed to work more efficiently and will likely not run into more complexity. So then reliability, does the system feature behave as expected by both developer and user? Availability, can the system deliver its services when requested by user? Security, does the system protect itself and uses a user's data from unauthorized attack and intrusion? Usability, can system user access the feature that they need and use them quickly without errors? Maintainability, can the system be readily updated and new features added without undue costs? Resilience, can the system continue to deliver user services in the event of partial failure or external attack? So these are the functional, non-functional system requirements. So the influence of architecture of system security. So we want to look at how architecture, the software architecture, the impact it has on the security of the system as well. So we are going to be looking at different types of security and the way different security scenarios are put. Now, for instance, if you have your house, right, and you want to secure your perimeter, now you could start by putting electric wire fence around the building. Then maybe in the front door, you could put a bulletproof door, right? After doing that, with the bulletproof door, probably the locks can now be, maybe they can be, you can have maybe several places you can lock it. Then in each of the rooms, you have extra locks, you have security cameras and a host of others. But the question is this: the number of systems that you have, the number of security points or security measures that you have, does it really guarantee the security of that building you have erected? Right, so let's look at different scenarios. We want to look at a centralized security architecture. Now, of course, this is just an example of a Star Wars game. So the Evil Empire have stored the plan for all the equipment in a single highly secured, well-guarded remote location. Of course, this is called a centralized architecture. It is used on the principle that if you maintain all your information in one place, then you can apply lots of resources to protect that information and ensure that intruders can't get hold of it. So the question is this, and of course, when students are presenting their seminars and they have to talk about security that they have employed in their research work, then we ask them that if you have employed this type of security architecture, does it mean that having several security in one location, does it really secure your system? And oftentimes, from research, we have found out that having a lot of security in one location is a very dangerous venture, right? So unfortunately for the empire, in the example above, the rebels managed to breach their security. They stole the plan for the Death Star, an event which underpins the whole Star Wars saga. In trying to stop them, the empire destroyed their entire archive of system documentation, with who knows what resultant costs. Had the empire chosen a distributed security architecture with different parts of the Death Star plan stored in different locations, then stealing the plans would have been more difficult. Now, the rebel would have had to breach security in all the locations, which of course, probably you will just get into one or two, but other documentation will still be available for the empire to use. So let's now look at the concept of decentralized security architecture. The benefit of a centralized security architecture are that it is easier to design and build protection, and that the protected information can be accessed more efficiently. So if you have several systems, right, and maybe your data is stored in just one database and you build some security around that database, of course, to access maybe documents or information on that database quite easy. It is just direct from the terminals, right? Then you could also deploy a lot of security. That is about the benefit of a centralized security architecture. However, if your security is breached, then everything you have is gone. If you distribute information, it takes longer to access. That's, of course, one of these disadvantages, right? To access all of the information and cost more to protect it because you have to deploy protection for each of the locations that you are protecting. So if security is breached in one location, you only lose the information in that location. So we want to look at the effect of architecture on maintainability and performance. So in the next, in this diagram, right, the first figure shows a system with two components, C1 and C2, that shares a common database. Assume C1 runs slowly because it has to reorganize information in the database before using it, right? That means once you access it, for instance, you have a data stored like an Excel sheet stored in the database, right? You access the database. Now let's assume the information on that Excel sheet is not arranged. For instance, you have them arranged just haphazardly, but what you need it for is for it to be arranged maybe alphabetically or ascending or descending order with matrix numbers and all that, right? So it takes you more time to be able to reorganize that information in such a way that you present it to the terminal for use. Now, the only way to make C1 faster might be to change the database. This means that C2 also has to change, which may potentially affect its response time, right? So if you have, okay, assume that C1 runs slowly because it has to reorganize the information database. The only way to make C1 faster is to change the database. That means that C2 also has to be changed, which may potentially affect its response time, right? Now, in the second figure, now this is the figure this. Now, a different architecture is used where each component has its own copy of the part of the database that it needs. If one component needs to change the database organization, this does not affect the other components. So it just continues to work. However, a multi-database architecture may run slowly and may cost more to implement. Now, a multi-database architecture needs a mechanism, which is component C3, to ensure that the data shared by C1 and C2 is kept consistent when it is changed. Now, of course, I'm sure you are doing some courses on database administration, right? Now, this is the last statement is important, especially when it has to come to maybe a module or a procedure call, a function call, or a nested, a recursive call. Now, when you have a program module calling a section or calling a program and it leads to another program calling it. Now, if that is done, there's a need for you to keep a stack where you keep all this information in such a way that you do not update an ongoing procedure. Now, if a procedure is calculating something, you do not mistakenly upgrade it when it has not returned the result of its calculation. So a C3 is needed to keep consistency. Now, this is the diagram. You have user interface, you have C1, C2, sharing database, having individual database C1 and C2, right? So this is a place where the database is reconciled for consistency. Now, consistency is a major issue in database administration. For instance, you'll find out that if you have gone to the bank to withdraw some funds, especially at the ATM, and probably you were debited, but some funds were not, your fund was not released to you. Now, if you go into the bank immediately, there's a likelihood that they will send you out, that you should wait that after 24 hours or less than 24 hours, the money will be back into your account, right? This is what you call a rollback. So there's a database of previous activities, maybe that you have done yesterday, which is, of course, you have certified that is correct, they save it. Now, once there's a withdrawal, today's withdrawal, there's a temporary database that is created, right? You withdrew 10,000 naira. Let's assume you have 100,000 naira in your account. You withdrew 10,000 naira. A database of your withdrawal is shown, right? A database of what you have left, which is 90,000, is shown. Then another database, which was your balance as at yesterday, is also available. So what happens now is that as soon as there's a problem, now the database of withdrawal, which is not successful, is now used to update the intermediate database that was created. So once that has been done, it reverts your balance to become 100,000 as against putting it permanently on 90,000. So this is what reconciliation of data. Well, I'm not a bank person, but at least we know the internal working of what the bank, the interior of the bank looks like. So this is for the first example that we looked at, where C1 and C2 share the same database. So if this database be corrected to suit C1, then to affect the operation of C2, right? So let's continue. So issues that affect, that influence architectural decision. So we have the non-functional product characteristics, the software compatibility, the number of users, software reuse, then the lifetime of the product. So let's look at that. So non-functional product characteristics such as security and performance affects all users. If you get this wrong, your product is unlikely to be a commercial success. Unfortunately, some characteristics are opposing. So you can only optimize the most important. Now, you should know what is the in thing. Now, why do you think that a product as Instagram will be more successful than probably a product that uses less of data for its functionality? It is what is put as part of the non-functional characteristics of that product that makes, though we cannot optimize the excessive consumption of data, but we can make the use more interesting for users by creating avenues where they can enjoy themselves. Now, I think of course a number of apps that have gone into extinction because of their hard and fast rule. For instance, some of them we tell you to authenticate several times before you can get to where you are going. People are not ready to be wasting their time doing a number of authentication and all that. So if you do not get your non-functional product characteristics very well, there's a problem that it will not succeed commercially. The product lifetime also affects the influence the architectural decision. Now, if you anticipate a long product lifetime, all right, you will need to create regular product versions or revisions. You therefore need an architecture that is evolvable so that it can be adopted or adapted to accommodate new features and technologies, right? I think when WhatsApp started, it only started with text messaging. Well, I'm not sure. It only started with the ability to text messages, right? But when the need for other communication requirement came up, it had to add maybe voice call, video call. Then, of course, it improved to extend to delivery notification. It extended to using status, right? And some other add-ons. I did not emphasize that these products will be extendable, right? This architecture would have been designed to be maybe an hard and fast stuff that, okay, this is about the only thing we can do. Now, and I'm sure that they would have been emphasizing the deployment of the 5G technology. They would have also left other spaces for evolving. Of course, before, you know, the radio services, they say you can only hear radio. But now, right from the radio station, you can see them stream some of the programs they are doing online. Before, a radio presenter can just dress very shabbily and go to work. But now some of them are beginning to x-ray the way they dress. They dress very nicely as compared to those on the television station that we have to be in front of the camera. Their attires will be looked at, will be criticized and all that. So these are the things that changes in technology, changes in a lot of areas of life affects the way a software should be. At least you should be futuristic in your design of any software product. Then the reuse. You can save a lot of time and effort if you can reuse large components from other products or open source systems. However, this constrains your architectural choices because you must fit your design around the software that is being reused. Well, of course, you have a lot of service-oriented architecture in programming styles, right? You have libraries that have been pre-compiled that you could just create an interface, call the library to do what you need to do and return results to you. So that software reuse has to do with compilation of library how those libraries can be easily used. I'm sure you are conversant with open source software, but the only disadvantage is that your architectural choices must fit around the software that is being reused. So you will not have the opportunity to be more creative in presenting a new architecture. Then the number of users, when you are developing a consumer software delivered over the internet, the number of users can change very quickly, right? This can lead to serious performance degradation unless you design your architecture so that your system can be quickly scaled up or scaled down. Now, I think when Facebook started, it was just for a local university. But as he saw business opportunities in what he was doing, he had to shut down Facebook, right? Reconfigure the architecture to emphasize the growing number of people that will be coming up on Facebook. So when it came up again, every other changes was not as hard on Facebook as it was then when it started. The traffic was enormous, so he could not cope with the traffic that was coming on the system. So that led to the redesign of the architecture of Facebook. Then software compatibility. For some products, it is important to maintain compatibility with other software so that users can adopt your product and use data prepared using the different system. This may limit architectural choices such as the database software that you can use, right? So software compatibility, that's the architectural design, can also be affected by compatibility with other softwares that you may want to use. Now, there's some software that you want to install on probably, okay, I think one of the major ones that you can come to terms with is the Windows OS, right, and the iOS. So these people are in this kind of unhealthy rivalry that whatever you can install on one cannot be installed on the other. So they are always peers. Even on their Play Store, they have different Play Store. So this leads to duplicity of efforts, and it becomes, in fact, even in the design of hardware, it becomes an issue to resolve these problems that you have created. But as a software designer, you should create an architecture that is able and that is compatible with existing softwares or softwares that may be released in times in a later time. So let's look at the trade-off. We want to look at the trade-off between maintainability and performance. Now, system maintainability is an attribute that reflects how difficult and expensive it is to make changes to a system after it has been released to customers. You improve maintainability by building a system from small self-contained parts, each of which can be replaced or enhanced if changes are required. In architectural terms, this means that the system should be decomposed into fine-grained components, each of which does one thing and one thing only. However, it takes time for components to communicate with each other. Consequently, if many components are involved in implementing a product feature, the software will become slower. So you can see the comparison between maintainability, trying to create a system that is easily maintainable. So how do you create that kind of system? You decompose this system into components that are in a way isolated. That means they can just stay by themselves. They can self-exist. However, there will be a need for communication between these systems. There's this individual components that are self-existing. Now, that isolation calls for communication. And once several systems have to communicate, it leads to a lot of trouble or a lot of issues, right? Trying to measure the performance of the system, as it were. So there's always a way as a programmer or as an architectural person or a software architect check. Okay. Sorry, my system is eating up. Okay, so what I'm saying is that for you to create a system that is easily maintainable, there must be a trade-off or a balance as an architect, a balance between the performance and how easy is it to maintain. So a way of doing it is probably, instead of having self-existing systems or self-existing components, you could also group those who can exist, who can coexist. For instance, if you have in a class, let's say on this class now we have about 78 students, right? Let's assume that we want to put all of you in to sleep over in the university. Now, it will be very difficult to just merge all of you together because, one, there will be complexity in the way you want to sleep. Some may want to remove their clothes to sleep, right? Some may want to remove their glasses. Some may want to remove a lot of things, remove their shoes and all that. But we may have it simpler if we separate the female from the male. Now, there's a way the female in the class can communicate and the way they can cope with their own sleeping style, and there's a way the male can cope in their sleeping style. So instead of having individuals having to communicate, you could bunch them up into groups that have similar identity. So in balancing maintainability and performance, you have to just know as a software architect how to go about this so that you don't get a system or a software that be too slow for delivering the required solution that it should have, right? Right. So let's look at trade-off between security and usability. So you can achieve security by designing the system protection as a series of layers, as shown in this figure, right? So you have different levels of authentication here, there. Okay, so let's look at the trade-off. Now, an attacker has to penetrate all those layers before the system is compromised. So it will take a lot of time for any attacker that's in a place of security to get into all the layers. Now, layers may include system authentication, a separate critical feature authentication layer, an encryption layer, and so on. Those are security models. Now, architecturally, you can implement each of these layers as separate components so that if one of these components is compromised by an attacker, then the other layers remain intact. So how does it affect usability? For instance, I, as an individual, as I think I mentioned it, there's a possibility that you do not want to always authenticate repeatedly. Imagine that you, as an individual, will have to supply password to each of these layers. You supply one here, supply one here, you supply one here. Now you want to use it the next day. Oh, sorry, let me use my. You supply. Sorry, I think I might use this. Okay, so you supply a password here, you supply another password here, you supply another one here. So the next day you want to use it, you go through these processes again. Now it becomes very cumbersome for an average user. So how does it affect usability? Now, a layered approach to create to security affects the usability of software. Users have to have to remember information like password that is needed to penetrate a security layer. Their interaction with the system is inevitably slowed down by security features. Now, many users find it irritating and often look for workaround. If so, uh, around it so that they do not have to re-authenticate to access features or data. So you can see one smart way that Facebook did was that if you are logging, if you create a Facebook account and you have to log on, right? They will just bring your picture and tell you that when next you are coming here, you don't need to type in your password, you don't need to type in your what's the name of this stuff? Email address. You just click on your picture and you land on your page. Now that's a smart method or a smart way of escaping users being bought. So in creating security and usability, you have to balance how you want to present your security in such a way that it doesn't affect the people using your system or any of the system. Now, to avoid this, you need an architecture that doesn't have too many security layers, that doesn't enforce unnecessary security, and that provides helper components that reduces the load on the user. Just have explained for the case of Facebook. So let's look at the trade-off between availability and time to market, right? So availability is particularly important in enterprise products, such as products for the finance industry, where 24 hours in 7 days operation is expected. The availability of a system is a measure of the amount of uptime of that system. Availability is normally expressed as a percentage of the time that a system is available to deliver user service. That means it is critical for banking sector or any other sector that provides 24-hour services to be on at all times. Now, if there is a problem with the system being used and probably the server goes down, now that's when you see a lot of people say, you go to bank and you see those terrible bankers, they will just look at you and they will pull their glasses down and be looking at you from up of their glasses. And they will look at you, well, we are working on it. He's not doing anything, he's just sitting behind the system. Instead of him to tell you that, look, the server is down or the network is down, you can go and come back, they just prefer that you should sit down for several hours, wasting your time, right? So the availability of a system is measured or is expressed as a percentage of the time that a system is available to deliver service. All right. So architecturally, you achieve availability by having redundant components in a system. However, having these redundant components can also raise complexity issues. So let's continue. To make use of redundancy, you include sensors, right? That's to pick up maybe a failure somewhere. That's a sensor component that detects failure, and switching components that switch operation to a redundant component when a failure is detected. So, for instance, if your house is well automated, right, and okay, you have a sensor-based gate, right? That if your car approaches the gate at a proximity, the gate automatically rolls open or swings open, right? But a time may come where probably the power source has been cut. That means there's no power supply. So what do? You can create a redundant service in such a way that a sensor detects that, look, there's no power supply. So let's roll over to, what's the name? Inverter. Now let's assume that the inverter is not able to push the rotor of the gate, right? So what you do is that you can now resort to a situation where once your car approaches and there's no power supply, the gate will just jack open to at least a particular distance where you can now come out by yourself to push it open. Now, let's assume that the gate, as soon as there's no power supply and your inverter is not able to power the gate, that means you'll be locked outside forever. So the essence of putting sensors and switching devices is for sensors to detect failures, right? And also to switch to another method of providing the same solution or near same solution that the main system is supposed to provide. Now, implementing extra component takes time and increases the cost of system development. It adds complexity to the system and therefore increases the chances of introducing bugs and vulnerability to the entire software. So, having looked at the trade-offs, now let's look at the architectural design questions. Now, how should the system be organized as a set of architectural components, where each of these components provides a subset of the overall system? The organization should deliver the system, to deliver the system security, reliability, and performance that you need. Now, how should these architectural components be distributed and communicate with each other? Now, what technology should you use in building the system, and what component should be reused? So these are the questions that comes up once you are considering your design of your architectural framework. So let's look at the component organization. So the first thing is abstraction. So what's abstraction? Abstraction is in software design means that you focus on the essential elements of a system or software component without concern for its detail. Now, for those of you who did some physics, the first law of motion is that a body will continue in a constant velocity, right? Except an external force acts on it to behave otherwise. So, and the first law of motion is written that V equals to U plus AT. So that is a form of abstraction. You have abstracted the component of motion, of speed, of everything to just maybe 4 alphabets: U, V, A, and T, and giving the relation as so. So, however, if the car starts from an initial velocity 0, that means U will be equals to 0. So you have your V to be AT. So you don't need to bother about, the car is big, the car is small. No, just abstract what you're supposed to do about the system into what is easily understandable. That's abstraction. Now, at the architectural level, your concern should be on large-scale architectural components. The composition involves analyzing these large-scale components and representing them as a set of fine-grained components. So, if you have if you have an architectural framework, right? You take the blocks first, right? So these blocks can now be broken down into different subcomponents. So these subcomponents, you can now develop algorithms for each of these components. Then the implementation can also come up. So the composition involves analyzing these large-scale components, and representing them as a set of final grain components. Now, layered models are often used to illustrate how a system is composed of components. So, for instance, you have the first guide there, which is the web browser. The second one, user interface. The third, information retrieval. The next, document index. Then the next, basic service. Then the other one, databases. So the first one for web browser, that is the bigger picture. So what are you supposed to consider on the web browser? You have the user interaction, the local input validation, the local printing. So that is all that you have to break them into fine details. And also for user interface management, you have authentication and authorization, form and query manager, then web page generation. Then for information retrieval, you have the search, document retrieval, rights management, payment, accounting, right? So document indexing, you have index management, index query, index creation, then basic services, database query, query validation, login, user account management. Then databases, you have several databases. So architectural complexity. Complexity is a system, in a system architecture arises because of the number because of the number and the nature of the relationship between components in that system. Of course, we're looking at trade-offs, and we said that you create several components. And of course, these components will also have to communicate, which may lead to the system being slowed down, right? So complexity in a system architecture arises because of the number of these components, and also the nature of the relationship between these components too. Now, when decomposing a system into components, you should try to avoid unnecessary software complexity. So how do you do that? The first thing is localized relationship. Now, if there are relationship between component A and B, these are easier to understand if A and B are defined in the same module. Just like the example I gave, that if you want, excuse me, you want the students to stay back, right? And you have females and male. The female may share the similar attributes in their sleeping pattern, or how they can cope when sleeping. And the guys could also share similar patterns. So you could just look for one curtain and just put it in between the class. So female will be by one corner and male will be by the other corner. So those that have similar relationship, they can have what is called localized relationship, and they can be put in the same module. Also the next thing is to reduce shared dependency. Now, where component A and B depends on some other components or data, complexity increases, because changes to the shared components means that you have to understand how these changes affect both A and B. Now, let's assume that in that same class, you have that let's assume that A is for the ladies and B is for the guys. Let's assume that one sub A, which is AX or AI can be maybe 1 to N, where N is a figure, or maybe N is maybe like an Arabic numeral. Then B to I is from I to N, right? So if A, the female, has maybe her husband is B something. Now there's a relationship which is more complex. Now you have A to have to relate with B. That means probably they have to sleep somewhere in the same place, right? Now that's a complex situation to resolve. So I say where component A and B depends on some other components or data, complexity increases. So how to get you guys to sleep in the class becomes more complex, right? Because changes to this shared component means that you have to understand how these changes affect both A and B. The question is that, can A, the female, sleep with the females, or can she relocate and go and meet the husband where the other guys who are the guys B stay? Now, is it not going to affect the way guys will compose themselves and a host of other things? So these are the things you need to reduce. Now, it is always preferable to use local data where possible and to avoid sharing data if you can. So to solve this problem, we can have a policy that no, we are not going to allow husband and wife to sleep together, at least for that night, just stay in different places, right? Then at least the next day you can go home and go and meet yourselves. So now, example of component relationship, we have C1 is part of C2. So this is C2, at least it's a part, or C1 is a part of C2. Then this one, C1 uses C2. So there's a call from C1 to C2. Then C is located with C2. This is what we call co-location. So you have a big box, you have C1 and C2 co-located. Then we have C1, excuse me, shares data with C2. So these are the various, excuse me. So these are the various shared relationship that you could have. So I think I put one example that I designed by myself. So I just pulled it out from one of my works to see what some of this component looks like. Now, this is a system for us to anonymize images, right? So the process of anonymization has different stages. Now you see this, where is this annotation? Now you see this first guy here, this box, it encompasses us getting medical images. So this is sourcing for medical images. So we could source for medical images from isolated databases, other sources, digitizing of hard copies, file servers, or stored images. So these have similar attributes of getting medical images. So these images can now be populated in a database. Then they are passed through the HL7 protocol. Now, then the anonymization process, anonymize database of images, that's you anonymize, then you store this data in anonymized. So if you look at this relationship, it's a dual relationship or a bi-directional relationship. This one can call this, and this also can call this. Then this is a directional relationship. You extract feature from this anonymized image, then you do an indexing of the image. Then this is a search algorithm here, then a printout, or you can use it to teach radiologists who are young, right? So these are, sorry, clear drawing. So these are the stuffs in developing some form of architecture. So the next thing to consider is architectural design guidelines. What are you supposed to look at? The first thing is separation of concerns, stable interfaces, implement once. So let's look at it one after the other. So each layer in an area of concern is considered separately from other layers. Look at this. This is a layer of concern. The one in sky in brown is a layer of concern, right? So it says, excuse me, each layer is in an area of concern is considered separately from others. So you group those who are similar. You group the male different from the female. Now, the top layer is concerned with user interaction. The next layer down with user interface management. The third layer with information retrieval and so on. Now, within each layer, the components are independent and do not overlap in functionality. So here, you have them, they have similar things to achieve, but they are distinct components. Excuse me. The lower layer includes components that provide general functionality, so there is no need to replicate this in the components or in the components of the higher layer. Yeah, I'm sure you can see my screen again, Abby. Yeah, can you still see my screen? But you're out of the class. Oh, thank you. Oh, you're still seeing my screen. Okay, that's interesting. Let me see. Oh, thank you. You can still see my screen. All right. All right, thank you. You can still see your screen. Thank you. All right. The lower layer includes components that provide general functionality, so there is no need to replicate this in the component in the higher layer. So you see, in this diagram that we have here, we do not have to replicate getting data, because this data that we have to go through pre-processing. So we cannot be introducing getting data at this blue place. Oh, you can see this way. This, we cannot be introducing data acquisition here again, because once we get data here, the data is pre-processed. The data getting here is different from the data we have gotten here. So the actuarial model is a high-level model that does not include implementation information. So just put them here. It's just like a guide. The way it's going to be implemented, the language is going to be with which it will be implemented. Now, this is the database. The kind of database used here is not specified. So you do not bother yourself with implementation information. Ideally, components at level X, say, should only interact with the API of components in level X minus 1. That is, interaction should be between layers and not cross-layer. So the flow, it's talking about flow of thoughts. There should be a flow from one place to the next, to the next, to the next, to the next, not having this interacting directly with this, right? So these are the things that you need to consider generally when you want to design any database guideline of a layered architecture. Now, cross-cutting concern. Cross-cutting concern are concerns that are systemic. That means it goes from the first layer to the last layer, i.e., they affect the whole system. In a layered architecture, cross-cutting concern affects all the layers in the system, as well as the way in which people use the system. Now, cross-cutting concerns are completely different from the functional concern represented by layers in a software architecture. Every layer has to take them into account. So every layer you design, we have to take into account as it affects this cross-cutting concern. Let's go back to our informal example where we separate the female and the male. Now, you see, I'm a male, so I can talk for the male. Once a guy wants to sleep, once he's tired, he doesn't care if he's wearing his shoes, his belt, his anything. He just lies on the floor anywhere and is gone till the next day. But women are more careful. They have to probably remove this, remove that, just to get comfortable. You see, they have a way or they want to lie down and a host of others. So these are concerns that course through the two groups. How do you want to sleep? Do you wear your nightgown? Do you wear your socks? Do you wear your head warmer? Do you have to bath before you sleep? And all those concerns. These are concerns that course through. But when it comes to separating them, they have female and male. That is not cross-cutting. It cannot go through all the layers, but we have that male separate, female separate. But the way we sleep is cause concern for the two sides, right? Every layer has to take them into account, and there are inevitably interactions between the layers because of this concern, right? Now, the existence of cross-cutting concern is the reason why modifying a system after it has been designed to improve its security is often very difficult. So you see those arrows going downwards, going downwards. These are cross-cutting concerns: security, performance, reliability, the infrastructure, the operating system, and the hardware. So it cuts across all the security, cuts across user interface, application, infrastructure, it cuts across performance, cuts across them, reliability cuts across them also.
Yeah, don't worry, I'll soon join you guys.
Yeah, please give me a few minutes. I will soon be with you. Or 2 minutes.
Yeah, I think there's a problem with the other connection. Yeah, but can you hear me? Oh, okay. Okay, thank you. Already, Rinzi. All right, I think Elte has decided to run away. So let's wait a bit to continue with thoughts. Mr. Olani there, you came late for classes. Okay. Yeah, started they're coming late for classes too. All right, I think the network is back. So can you hear me? It appears I can't hear. Okay, I think I can hear you. Oh, yeah, I think there's a problem with this other. I'm using my system and the other one. So yeah, the network is running forth and back.
Mr. Olanite, I can see you're in class. I'm only raising an observation that you came late. It's breaking now. Uh-oh. But is it better? Yeah, can you hear me clearly? Network is bad, sir. Oh, okay, thank you. So let's just continue. I hope the network will not run away again. So we want to look at security as a cross-cutting concern. So security architecture, different technologies are used in different layers, right? Such as an SQL database or a Firefox browser. Attackers can try to use the vulnerabilities in these technologies to gain access, right? Yeah, consequently, you need protection from attacks at each layers as well as protection at lower layers in the system from successful attacks that have occurred at higher layers. So the issue is that if you say you do not want the upper layer to, okay, let's say you do layer X to interact with X minus 3, which is a cross-cut, which is maybe a level not immediately after that layer. But if the user interface is breached, and that is the only place where you have your security placed, then there's a problem. Consequently, an attacker will just run through the whole system. So if there's only a single security component in a system, this represents a critical system vulnerability. If all security checking goes through that component and it stops working properly or it's compromised in an attack, then you have no reliable security in your system, right? By distributing security across layers, your system is more resilient to attack and software failure. But remember that once security is distributed across all these platforms, make sure that the only place that a user can authenticate, the authentication for a genuine user is still made as simple as possible. Okay. So a generic layer architecture for web-based application. You have browser-based or mobile, browser-based or mobile user interface, authentication and user interaction management, application specific functionality, basic shared services, transaction and database management, right? So layer functionality in a web-based application. So browser-based or mobile user interface, a web browser system interface in which HTML forms are often used to collect user input. JavaScript component for local actions such as input validation should also be included at this level. Alternatively, a mobile interface may be implemented as an app. So authentication and user interface management. The user interface management layer that may include components for user authentication and web generation. Application-specific functionality, an application layer that provides functionality of the application. Sometimes this may be expanded into more than one layer. Basic shared services, a shared service layer which include components that provide services used by the application layer components. Database and transaction management. The database layer provides services such as transaction management and recovery. If your application does not use a database, then this may not be required. Now, can we give examples of applications that do not require databases? Assignment number 4 or assignment 2. Assignments give specific, or give 10 applications that do not require the use of databases. So I'm sure you are still conversant with our island our island software, where users can, the teachers can configure for students, check the students for plagiarism issues and issue of copyrights and all that in the previous lectures, right? Now, the island architectural design principle. Now, it should be possible for users to replace, replaceability. It should be possible for users to replace applications in the system with alternatives and to add new applications. Consequently, the list of applications included should not be hardwired into the system. Extensibility. Now, it should be possible for user or system administrators to create their own version of the system, which may extend or limit the standard system. Age appropriate. Alternative user interface should be supported so that age appropriate interfaces for students at different levels can be created. Now, I'm sure for some of you who have this iPad or notepad for your words or your children. Now, for the first configuration, you have to configure it on the parent interface first before you could now tick what they can do on their own interface. So you are advised to password your interface, right? Then you launch their own interface. So this is a form of architectural design which helps you to protect your children from getting to harmful sites on the internet. As a matter of fact, some tabs like Amazon, they keep you abreast in your email of where the children are visiting, what they are downloading. Maybe if what they are downloading costs some price, they will notify your email. So I think this is a design, architectural design issue that is also in tandem with the island system that we looked at. The description of that young man who lives very close to coastal region. I'm sure you still remember that fellow who wants the children to populate the database with reminiscence of pictures gotten from their parents, right? And also the ones they can get online. Yeah, do you still remember that? Yes or no? No or yes? We are waiting for response. So you still remember that system that we described, the island system? Okay, Mui, thank you very much. I think we should give Mui an award. He's always responding fast. And Olanite, Farid, thank you very much. Much appreciated. All right. So if you don't know, please visit the other videos. Right. So let's continue. Prince, thank you. So programmability, it should be easy for users to create their own application by linking existing application in the system. Now, minimum work, users who do not wish to change the system should not have to do extra work so that other users can make changes. Moving forward. So what are the design principles in the island software product? Our goal in designing the island system was to create an adaptable universal system that could be easily updated as new learning tools becomes available. Now, this means that it must be possible to change and replace components and services in the system, principles 1 and 2. Replaceability, extensibility, that's the principle. Right? The next one, because the potential user system span an age range of from 3 to 18, okay, we need to provide age-appropriate user interfaces and to make it easy to choose an interface principle, right? Or user, so this is age appropriateness, right? Where are we? So principle 4 also contributes to system adaptability, and principle 5 was included to ensure that this adaptability did not adversely affect users who did not require it. All right, so please get a paper and a biro. I want to give you another assignment that has to be typed and submitted individually. You can see some people are just joining the class now. You see, what I'll do from next class is I'm going to have to place all of you in waiting room. So the people who get to the class before 3, I'll let them in and I'll continue my class like that. Some people will wait till when it's almost time to take attendance and they will start rushing to join. That's unacceptable. So look at this diagram, and based on what I've explained, please write extensively on the design principles as it affects this framework. So you can take a snapshot of the framework if you want, or you can go and look up on the YouTube. So you write extensively on this framework as it affects design principles. So the design principles are replaceability, extensibility, and age appropriate. Now, for this age appropriateness, you should replace it with user appropriateness, right? So in this diagram, you find out that the users can be at least this is a medical research, right? The reason why people don't join on time, I'm coming, I think there's an information here. The reason why people don't join on time is because we just finished physical class and majority of the students are on the road with the old hustle and bustle of Lagos. Sorry, sir. Sometimes the class before your class used to end past 3. Look, I think, you know, I'm also teaching a class 2 hours before this class. So I had to quickly finish that class and rush to start up this meeting. Excuse me. And I'm sure that your timetable extends to 7 p.m. So if you have to be in school till 7 p.m., would you give excuse as that, okay, probably there's hustle and bustle? You have to leave when the lecture finishes by 7 p.m. And if you don't want to stay till then, you go home. So I find it somehow that I will be in class and some of you will be joining at your own time. It's not cool at all. It's not. So I hope you get a new lease of your attitude towards the class. Oh well, that is that about that. Coming on. Yeah, sorry, is this thing still going up on YouTube? Mr. Olanite, can we solicit for physical class? No. Network takes people out sometimes. What's yes, sir? Can we solicit? Network takes people out sometimes. No, I understand network can take you out, but if network takes you out, it is not that maybe 30 minutes to the end of the class, you just see the class jumping from probably 70 to 90. Now you are 90 now. So how do you explain network? It's not ideal. Yeah, Mr. Lanite, can you copy the live Zoom, the live chats? Sir, the network in computer science department is terrible for the department that is about computer and technology. Yes, sir, YouTube is answer. Okay, thank you, Mr. Lanite. Can you copy the address of the YouTube and place here so that they can look at it? Well, I think it's 350, 453. You can pick up your, what's the name? You can start sending in your attendance. Mr. Lanite, please raise up your hand so that I can make you a co-host. Where's Mr. Lanite? Anusama. Okay, let me search for you then. Hola. Okay, I've seen you. Oh, sorry, I have to go to the other. I've seen your handle. Yep. Post. Yes. All right, so Mr. Olani there. I think you are the host now. So this is the assignment. You write on this architectural framework on design, on the design principle. What page was I? Okay, on these design principles. So designing airline principle as a service-oriented system. This principle led us to an architectural design decision that airline system should be service-oriented. Every component in the system is a service. Any service is potentially replaceable and new services can be created by combining existing services. Different services delivering comparable functionality can be provided for students of different age ranges. So service integration. Full integration services are aware of and can communicate with other services through their API. Partial integration services may share service components and databases, but are not aware of and cannot communicate directly with other applications. Okay, Celestine Uche. Yeah, what's the problem, Celestine? Yeah, can you send your message, please? I hope it doesn't get missing in the attendance that we have. Celestine, I'm waiting for what you have to say. Okay, let me continue. Then independent. Now, these services do not use any shared system service or database, and they are unaware of any other services in the system. They can be replaced by any other component service at any time. So a layer architecture model for the island system. This is what it is. So distributed architectural, okay, let me see. I'm not seeing that guy's message. So distributed architecture. The distribution architecture of a software system defines the server in the system and the allocation of components to these servers. Right? The first what we did was the centralized system, using that game as a scenario that if you lose the server, if there's an infiltration on your location, you probably lose everything that you have. But if you have distributed architecture, it's a bit safer. So client server architectures are a type of distributed architecture that is suited to application where clients access a shared database and business logic operation on the data. In this architecture, the user interface is implemented on the user's own computer or mobile devices or device. Functionality is distributed between the clients and one or more server computer. So this is a client server architecture. So can we have the list? Who is this fellow? Sorry, I think I just saw the question the guy was asking. So can we have the list of assignments that have been given? Really? Were you not listening when I was talking? Oh boy. So this this is the server, load balancer, then the client sends a request and receives a response. Now the model view controller pattern, right? So client server communication. Client server communication normally use the HTTP protocol. The time is up, but I need to quickly finish. The client sends a message to the server that includes an instruction such as get or post, along with the identifier of the resource, usually a URL, on which that instruction should operate. The message may also include additional information, such as information collected from a form. HTTP is a text-only protocol, so structured data has to be represented as text. There are two ways of representing this data that are widely used, XML and JSON. XML is a markup language with tags used to identify each data item. JSON is a simpler representation based on the representation of objects in the Java language. So this is multi-tier client server architecture. You have the clients, you have the web server, application server, and database server. Right? So service-oriented architecture. Services is a service-oriented architecture. In a service-oriented architecture, as stateless components, which means that they can be replicated and can migrate from one computer to another. Many servers may be involved in providing services. A service-oriented architecture, as demand increases and is resilient to failure. So these are clients, the web server, the service gateway, and the services provided. In the next chapter, we are going to be looking at cloud services and some of the classes of services that can be provided. So issues in architectural choice, data type and data updates. If you are mostly using structured data that may be updated by different system features, it is usually best to have a single shared database that provides locking and transaction management. Now, if data is distributed across services, you need a way to keep it consistent, and this adds overhead to your system. Of course, if you are doing database, you can also look at this in database management. Of course, you'd have done that concurrency management. Then change frequency. If you anticipate that system components will be regularly changed or replaced, then isolating these components as separate services simplifies those changes. Now, some of course, you know, I visit some social media sites, of course, to post and also to read some things, but oftentimes I also look at the flaws in the architectural designs, right? Now, there was a time that Facebook was caught pants down. Now, if you notice that you have posted a particular post, right? You see that, okay, probably 10 people have commented and 20 people have liked your posts. Then the next day you come back and you find out that those comments have disappeared. Not that they deleted them. The stuff that you have, the other system that you access the stuff is still showing you that you have 20 people have liked it. The other one is showing that it has reduced that kind of, at least I've caught them in that situation more than 4 times. So apparently there's a situation where one of the databases had been updated, right? And probably one of the databases lagged behind in the update, and it caused a lot of deadlock or issues with the database. So they just had to revert to the first known or the closest known state of that database. So you just have things being displayed on your screen, and You just, and of course, they don't give apologies. You have read their terms and conditions, so you have to accept. So if there's going to be frequent changes, yes. If you anticipate that system component will regularly change or replace, then isolating these components as separate services simplifies those changes. So the system execution platform, if you plan to run your system on the cloud with user accessing it over the internet, it is usually best to implement it as a service-oriented architecture because scaling the system is simpler. If your product is a business system that runs on local server, a multi-tier architecture may be more appropriate. So technology choice, database, platform, server, open source, development tools. Those are the technology choice. So you could look at that. No, database. There are two kinds of database that are now commonly used. The relational database, where the data is organized into structured table, and the SQL database, in which the data has more flexible user-defined organization. Relational database, such as MySQL, are particularly suitable for situations where you need transaction management and the data structures are predictable and fairly simple. NoSQL database, such as MongoDB, are more flexible and potentially more efficient than relational database for data analysis. NoSQL database allow data to be organized hierarchically rather than flat table. And this allows for more efficient concurrent processing of big data. Okay, so delivery platform. So delivery can be a web-based or a mobile product or both. Mobile issues, internet connectivity, processor power, power management, on-screen keyboards. So these are issues that you need to consider for mobile issues. To deal with these differences, you usually need separate browser-based and mobile version of your product front end. You may need a completely different decomposition architecture in these different versions to ensure that performance and other characteristics are maintained or are balanced. Then the server. A key decision that you have to make in whether to design your system to run on customer server or to run on or in the cloud. For customer products that are not simply mobile app, I think it's almost always makes sense to develop for the cloud. For business products, it's a more difficult decision. Some businesses are concerned about cloud security and prefer to run their system on in-house server. They may have a predictable pattern of system usage, so there is less need to design your system to cope with large changes in demand. Now, an important choice you have to make if you are running your software on the cloud is which cloud provider to use. So you're going to be looking at, I think, is it cloud service, a cloud something next class. Open source software is software that is available freely, which can change and modify which you can change and modify as you wish. The advantage is that you can reuse rather than implement new software, which reduces development cost and time to market. The disadvantage of using open source software is that you are constrained by the software and have no control over its evolution. The decision on the use of open source software also depends on the availability, maturity, and continuing support of open source components. Open source license issues may impose constraints on how you use the software. Your choice of open source software should depend on the type of product that you are developing, your target market, and the expertise of your development team. Another consideration, development tools. Development technologies such as mobile development toolkit or a web application framework influence the architecture of your software. These technologies have built-in assumptions about system architectures, and you have to conform to those assumptions to use development system. Development technologies that you use may also have an indirect influence on the system architecture. Yeah, the time is up. That's why I'm just running through. So developer users usually favors architectural choices that use familiar technologies that they understand. For example, if your team have a lot of experience on relational database, they may argue for this instead of another. So these are the key points of what we have learned today. So let me just keep it for a while. So you can pause and look at it on the YouTube channel. Thank you for listening. And I hope that you come for next class earlier, else you may be shut out of the class. So this is the assignment given, right? And we expect that you use the design principles to analyze that architecture, and you, of course, writing about 2 to 3 pages, right? You get that done. So, Mr. Olanite, are we submitting hard copy or soft copy?
Anyone that is okay by you, sir.
That is a political answer.
Soft copy is fine, sir.
Are you planning to contest for councillorship in Lagos State?
No, sir.
Or some of your classmates are there so that they will beat you up? Yeah, so please make your decision.
Soft copy is fine, sir.
Okay, so soft copy it is for now.
When are we submitting?
Yes, okay. I think you should. So today is Saturday. The assignment should get to me latest by Monday, 6 p.m. So you guys should get a way of getting around that. I think I'm seeing, I'm coming. I think I saw messages from Mr. Lanite. Oh, okay. You're helping with the cloud, the YouTube live, right? Okay. Yeah, so do we have any other questions before I log out? Questions? Okay, I think I should unmute all. So allow participants. So you can talk now. Some people are running away already. That's interesting. All right, so you can unmute yourself and talk if you have any concerns or anything to say. So let's listen. Is it happy time or something? Ghost time, is he in class today? Please raise it. Indica. Yeah, Unduke, please unmute yourself.
Yeah, good evening, sir. Thanks so much for the lectures and the timing. So I want to just talk about this joining, right? Because the way the class is structured now is free for someone to come in and go. Well, I don't know about going out, but if it is locked, it will be difficult, especially when the network drops. Right, because I remember last 2 weeks, I wasn't even able to connect back again. So I didn't even write my attendance, even though I was in class. So if we lock the access to the class, as per we coming in freely, it will be more difficult, So I don't know if we means, taking attendance maybe 3 times within the class section, just to check when you come in, when you during the middle of the class, and at the end of the class, for to have a record of our being in place or being in the class or through the section.
Well, thank you for that observation. Now, of course, I think your point is valid, right? But the issue now is this: if you do not log in on time, let's assume that the first set of people come in around probably 5 minutes after 3. Then before, at least you must form a quorum before it starts. So let's assume that you should be above 30 before the class commences. Now that would be like today we started
Yeah, you are muted, sir. I think got cut off.
Yeah. Can you get me that? Yes, I've been thrown out.
I think I'm back now. Yeah, so I will leave the class opened as you have suggested. The only thing is that what can we do? I'll just start the class instead of waiting for the guys to convene. Oluwatobi Dosumu, please, let's have your thoughts.
Okay, yeah. Good evening, sir, and thank you for this lecture. I just wanted to ask that can you please review the submission date for the assignments? It's barely 48 hours to
So
Monday.
when do you want us to submit?
I'll say a Thursday is fine.
Mr. Olanite?
Noted, sir.
So let's submit on Friday, 6 p.m.
Friday, 6 p.m. Noted, sir.
Is that okay with your own schedule?
Yes, Friday, 6 p.m. Very okay, sir.
All right, thank you for your time. So I think I saw some.
Thank you very much.
Sorry, I saw some people raising some issues on the chat. I'm coming. I'm trying to search for where it is, so that I don't let you guys. Yeah, sorry, I'm trying to check the chats. Okay, kindly help review the submission date for the. I think that has been done. I can't hear anything. Really? Obafemi Kazim, can you hear now? Or you have been thrown out just as I did. I think Airtel is having some issues. So, oh, I think you can hear now. Okay, sorry about that. Any other question? Sir, please, can we extend the submission date? Yes, we have done that. But again, I don't think there's any other question here. Yeah, and nobody is raising up his or her hand. All right. So thank you for attending the, I think I'm seeing plenty of messages again. Agbola. Oh, okay. I think I've read this one. All right. So we'll meet next week, God's willing. So we are in lecture 4. And of course, you should be expecting your tests anytime soon. Now, I've told you that the assignment you are submitting constitutes some marks, right? The attendance, the assignment, the tests. Then I'm going to ask Mr. Olanite to group you into a group of 10. As the number of registered students will be grouped into 10. So you're going to do two projects, right? So that project we also make up with the other 30 marks or 20 marks. So Mr. Olanite, you can start grouping them into different groups. Let them be 10. Okay, no, let the whole group be 10.
Okay, sir.
Yeah, thank you. So Mr. Nasir Bello.
Hello, sir. Good afternoon, sir.
Good afternoon, please.
Yes, sir. Yes, sir. Yeah, hi. Thank you very much for the knowledge impacting in us. So I actually want to solicit for the text scenario, sir. I would have loved, like you said, the project-based and assignments. Would have loved having that rather than having the text, sir, because that impacts more knowledge and it allows us to do more research than having a text that will just write a paper up to me, sir. I'm sorry, sir.
Well, thank you for your observation and your input. Well, the essence of giving out tests, right? It's not for students to fail, right? It's just for, for me, giving out tests is not to test if you know what you're supposed to write, but how can you respond to situation that you are not prepared for? Oftentimes, I don't tell you when your test will come up. You just see it appearing. So it's like testing on how you can become, like how you can respond to challenging situation, right? That's what I test. Now, if you look at my breakdown, it is a form of continuous assessment. That means your first assessment is, do you attend classes regularly? 2, do you submit your assignments? 3, can you work in a group? Then the last one is that, can you work individually? Right? So the tests, as it were, can just be 10 marks or 5 marks. But if it's a consensus decision from all of you that you don't want to have written tests, but at the same time, some of you will also go and copy assignments and submit. I've seen a lot, and I've given those people 0. You go and dub somebody assignment and you just put it as your own, you change the matric number. That is criminal, right? So if you feel that, oh, probably the assignments you have submitted, you have been having good grades, I'm sorry to say, the copy and the copier, you are scoring 0s. So, well, if Mr. Nasir said we should not do tests, I don't know if that's the opinion of everybody in class. If it is, then we adopt it. But if it's not, we throw it out. So can we put that to a vote? Those in favor of doing tests, we have 76 candidates in class out of 96, out of 90 something that were in class. So those ones have run. So if you support us doing tests, oh, sorry, the first one is this proposal. If you support us not doing tests, negation tests, can you please raise up your hand so we have a count? If you don't want us to do tests, Mr. Olanite. You are falling my hand.
No, sir, I'm sharing the phone with somebody, sir. They've locked the class. I'm sharing the phone with somebody, sir.
No, I can see your hands raised up now.
So I'm using her phone. So my name, but she's raising her hand.
All right. So how many people do we? All right. So out of you're increasing. 18, 19. Okay. So it's not yet half of the class. The voting will soon stop. 24, 25. All right. So let's stop that. Only 26 people don't want tests. All right. So can you please drop your hand? Drop your hand, please. Drop your hand, oh. 3 more people. Mr. Korede Olaiwola, Your hand is raised. Adora, your hand is raised. Muibi Taiwo, please raise up your hand. Sir, is this test online based or physical test? And please, sir, can we get the slides so that we can do what? We can really capture the slides per class. Now, those people raising up your hand, can you lower your hand? Huh? Some people are just not listening. Okay, I'll force you. Now, so those who want tests, I'm coming. This faculty is raising up his hand again. Okay, he has dropped his hand. Yeah, those who want tests, hands up. Anusama. Okay. One person. Okay, 2. Good. It's increasing. Good. 5. Okay. 6. I'm still waiting now. All right, so 6 people want test. Okay. Lower your hand. Oh, 8. Are you still voting? 8. All right, well, lower your hand. Undecided. Lower your hand, all of you. All right, so undecided. Anusama, raise up your hand. 1. All right. So this is a keenly contested election, but as a returning officer, when you add 25 plus 8 plus 1, it has not covered the population sample of the class. So we declare this election inconclusive. So let's watch how it turns out. Probably we have a test or we not. All right. So in the absence of no question.
Are you an INEC returning officer?
No, I presided over it now. So I have to declare the results.
Thank you, sir.
Okay. Elo or Ifere.
Sir, are you sure you are not in the wrong profession?
You know, I do a lot of research in different fields, so I'm quite versatile. All right, Mr. Elo or Ifere, your opinion, sir?
Good evening, sir.
Good evening, please.
Okay, quick one. You just mentioned that in case somebody copies your work, that both the copier and the one they copied from is 0. Now, where we submit our work was an open platform. If I submit there, all of my classmates sees it. Now, hearing this from you, I wouldn't really know who copied mine.
Oh,
so people
are you
can,
thinking
it's easy
you
for
have
somebody
0?
to go. Yes, I will not know. Because you saying it now, I will not know if my work was copied and I had 0. So I wouldn't really know. Because we actually submitted in an open platform where everybody saw everybody's work.
Wow, that's serious. So what are you going to do now? At least I cannot determine if somebody picked up your work and copied it. All I know is that the information I have is what I'm working with. So to that extent, I don't know what to do and I don't know what to say, but I'm only marking based on what I've seen. Mr. Ronald Madum, Roland Madum.
Okay, so it's regarding the copy and the person copied and person that they copied from. You know, some people can copy and they copy well. You know, so why they are being zeroed? You can also look at it from that angle. Not that I copy from anybody, but you know, it's just like a blanket giving all of them 0. If somebody copy from another person and then make it better, so you won't be able to just pick. Maybe the person that even copied did better than the person he copied from. So that has to be considered also.
Okay, somebody saying you assume that we use LMS. Yeah, the issue is that we have not all been registered on LMS for now.
Hello, sir.
Yes, Mr. Ronald. Well, thank you for your suggestion. So you are suggesting that we have halfway mark instead of 0. Is that your thoughts, Mr. Ronald?
Yeah, what I'm saying is actually very difficult to score 0. That I read somebody's material and I'm able to get something better and present, So why judging? How will you not judge the person? He copied good, but he copied well. His knowledge sharing.
All right. Well, I don't think I have a solution to that, but I will think of that. Then Ikechukwu Okafor, sir, we can send assignment to your mail. You send almost 90 copies to my box. That's a lot. Can we share your mail? That way only you have access to it. Yeah, the situation is having to start downloading one after the other. It's a lot of stress for me. And I don't have such time. I have a lot of things to do. Mr. Olanite, please, your observation. I think your hand was raised.
Considering the first assignment submitted, I don't think an ideal person will want to publish because it's supposed to be unique. At least that one we may assume nobody must have copied. Just an assumption, sir. Then moving forward, I don't know if the soft copies don't work. Maybe we can do hard copy in school to prevent that, because that sounds like the only option, sir.
Even hard copy, is it not soft copy? You translate to hard copy.
No, the soft copy, there was a Google document link where everybody dumps, where copying is made open. So you can just go there and select and even pick favorite of anyone you want to copy, sir. But if hard copy, everybody will bring it to class. Then whosoever exposes work may not be penalized, sir. But unlike the other one that you don't even know when you are involved in the...
Well, thank you for that suggestion. But at the same time, you see, I'm an advocate. Well, my research interests is in preventing global warming. That's carbon emission eradication. So the part of that is when you use too many paper, once I just read and I grade, what's that paper used for again? I don't need it anymore. So it goes to burn. We're depleting the forest that is used for making the paper. So that's why I prefer soft copy, so that one, you do not spend so much money printing out, then running up and down. Then sometimes you get your system infected with virus or your phone or your flash drives. That's what I want to prevent. But in trying to prevent that, there's going to be a balance that you do not copy somebody else's work. So there must be a penalty for copying, and there must be a way to protect the environment from global warming. So there must be a trade-off. I think I'm seeing some messages. Let me see. Where the copying is not done verbatim, students should not be scored 0. Okay, maybe I'll send those things to you so that you grade. Again, maybe we can take the assignment again. A lot of people miss the class. Someone like me missed the first class because I didn't know the semester starts that day, so I didn't take it. Well, the reward of not showing up in class is getting 0. We can check file property, check dates of modification and creation. You don't know, it's a lot of work. Okay. Obafemi Kazim, please, can we have your thoughts?
Okay, good evening, sir. Okay, I have a suggestion. I have a suggestion, but it might take a longer while. Maybe the governor can, in the general group, create a folder for each person and give access to the other person. So that way he can only send his assignment into that group, and only the governor and him can see what he has submitted. Nobody else will see it.
But what about his own time?
That's what I said. It can take a longer time.
Yeah, we should not overburden ourselves or anybody with so much work. That's my thoughts anyways, but it's a good suggestion, but it takes a longer route. Mr. Celestine Uche.
Good evening, sir.
Good evening, please.
Yeah, thank you for the lecture. It was very interesting, and I wish I've been attending. Actually, this is actually my first, but I really enjoyed the class. But I also missed the test, the previous one. So I don't know if we'll be given an opportunity to do that, to even have maybe a retake for those of us that missed. We really appreciate. And we also understand that you are strict about originality. So we also take that into cognizance while taking any of your assignments. So really appreciate. It's an interesting class. Thank you, sir.
Thank you, sir, for your comments and recommendation as well and taking humbly. Yeah, on the chat group we have, there should be a way of restricting only write access to Google Drive. Yeah, creating the folder is same thing as submitting it as email. That's true. And somebody is saying he prefers to do assignments than to attend to class. Really? Wow. Mr. Korede, is that you? Then there's one Mr. Henry Onyezi raising up his hand. Oh, is it a mistake?
Hello, sir. Can you hear me?
Yes, please.
So I was the one that said there should be a way to restrict only write access to Google Drive. In that way, you can only upload or put the file in the past, but you can't view or open what others have already put there.
Okay, sorry, I was reading something. Say creating the folder. Okay, so I think Google Classroom or Google Form can be created for submission. I agree with Henry. Sir, is LMS not an option? It is, but you see, having to enroll lecturers into the LMS has not been done because we're having physical classes. You know, I'm an e-learning officer, so I know what I'm talking about. Some people have submitted the enrollment list of their classes or their department since the beginning of semester, and that's not been done. So that is the issue why we are even making use of Zoom and providing the link if it's sent to you. So Oluwatobi Dusumu, it's an option, but it's not active. So Mr. Henry, please, your thoughts again.
So I'm saying that there should be a way to, when the governor is creating the Google part or the Google Drive for submission, you should restrict the access to only write. To mean that you only have to upload your file, but you can't view what others have already uploaded.
All right. Mr. Lanite, is that an option?
It's an option, sir. Just look into it, sir.
I think there's a network issue where
it's possible, sir. It's an option, sir.
All right, thank you. So I think that can be done. So the previous assignment, we should forgive those who copied and who were copied from, but going forward, we have zeros. I think that's okay. All right. So I don't think there's any concerns again. And, no hands raised. Mr. Henry, I think I've attended to you and your hand is still raised up.
Yeah.
All right, so please have a nice weekend. I hope the assignment is done in good faith. Bye.